Geometry Unit 14, Section 7, Deriving the Equations of Circles. So the previous lecture was on the equation of a circle, and you learned what the equation formula for a circle, x minus h squared plus y minus k squared equals r squared, something like x minus 5 squared plus y plus 3 squared equals 36, came from a center of 5, negative 3, a radius of 6, because we have radius squared when it's actually in the equation. And it's all about every point is the same distance to the radius. That's why we started off by showing the connection about the distance formula, and this is where this really comes from. So you need to be able to recognize this as the equation of a circle, just as you recognize something like y equals 2x plus 5 as a linear equation, and something like x squared plus 2x plus 7 as a quadratic equation. Well, if x and y are both squared, that it's a circle. It's also possible it could be a hyperbola or an ellipse, but we don't learn about those this year. So if you see x and y both squared this year, it is a circle. Um, and so we need to be able to recognize those equations, but sometimes they're kind of written a little weird, like this right here. Now I recognize x and y both being squared, so that's your hint that it is a circle, not to mention the directions say identify the center and radii of the circle. But to be able to see the center and radii, it needs to be in that circle standard form, like the parentheses x plus 5 squared, you know, and so from this, I could tell it's a circle, but I can't see the center and radius like I can when it's in this type of form here. So what we're tasked to do here is derive the equation of the circle. I want to rewrite this in a proper standard form so I can then see the center and radius like I did in the last unit. And the process we're going to do is something that is called completing the square. And this is something you learned actually last year. So this should hopefully be review for you. So first A and B, I want to complete the square, and this is review. Now, completing the square last year, now this is not a circle. It's a quadratic, right? This if this was a y here. And it's a trinomial, a parabola graph, a quadratic equation as a degree 2, next to the first, minus 41. Now, what you learned last year is you could turn a quadratic equation, you could solve for x, or at least turn it into something called vertex form. I could turn this into this. And how do I do that? So the first step, and we'll write some steps out here, is to set equal to c. And what I mean by that is you want to set it equal to the constant. Now, a quadratic typically has 3 terms. It doesn't have to have 3 terms. It could just have x squared. That just means it's a quadratic. But it typically has an a, b, c term. The third term here, we call it the c term because it's a third term. It also works out that c stands for constant. A constant is a number without a variable. Like we know there's a 1 in front of x squared here, and it's attached to that x squared. It's a coefficient of x squared, so it's attached to a variable. 4 is the coefficient of x to the first. It's 4 times x. They are connected, so 4 is attached to a variable. But this negative 41 right here, that doesn't have an x attached to it, is not a coefficient of anything. It is a constant. It is constantly negative 41 regardless of what x is. Like if x is 2 here, then this whole thing is 8. If x is 3, it's 12. But regardless what I plug in for x, this is still negative 41. It is constant. So it's called a constant. Basically, it's just a number without a variable attached to it. But we want to set it equal to the constant. What that means is I need to move the constant to the other side. And we're going to do that by typical addition subtraction thing. So I'll add 41 to the other side. That gives me x squared plus 4x equals 41. So set it equal to the constant. Now there's a step 2 that I'm going to put in red because it doesn't always happen. And that is if a does not equal 1, divide by a. And so you're not really going to see this here, but I guess you could at some point. Like if there was a 3x squared here, I would want to divide everything by 3. Everything. This, and this. Everything gets divided when we divide equations. Now, a is 1 here. And when a is 1, it's not written. So if you see nothing in front of x squared, then this step is good, and you could just skip it and move on. But if you do have a 2, a 3, a negative 2, whatever, you got to divide everything by that before you move on. And that actually could be step 1. But like I said, it doesn't happen every time, so I'm going to have that in a different color there. And then we'll do step 2. Well, it could be step 2 if you don't have this step, but we'll call it step 3. Add b divided by 2 squared to both sides. Now, what is b divided by 2? Well, just as this is the c term, this is the b term. But I want to think about it here because maybe I divided everything by it. So whatever the coefficient of x to the first is, that is your b term. So in this case, b is 4. And so I need to divide that by 2. So, and you can do this little math over on the side here. So b is 4 divided by 2 and then square it. So divide by 2 first and then square it. What does that come out to be? Well, 4 divided by 2 is 2 and 2 squared is 4. I need to add that to both sides. So plus 4x plus 4 equals 41 plus 4. All right. And then step 4 is factor slash simplify. And by factor, we mean 2a binomial squared. All right, I'll explain what that means. Now, the left side here, we have a trinomial, and it's now called a square trinomial. That's why this term is called completing the square. And so the right side, we could just simplify. 41 plus 4 is 45. But this left side is a trinomial that needs to be factored. And when you factor, it's going to, a trinomial like this, it's going to be what, I don't want to have that circle there. So equals 45. It's what AM, what adds to 4 multiplies to 4. And it's always going to work out, because it's a square trinomial now, that it's going to be the same number twice. So it's not going to be like 1 and 3 or 2 and 5 or negative 2 and 7. It's always going to be 2 and 2, 3 and 3, negative 5, something like that. So the numbers that multiply to 4 and add to 4 are 2 and 2. And the shortcut is it actually always works out to be your middle number b divided by 2. But you could also think of it as factoring. So because it's 2 and 2, I could write this as x plus 2 comma x plus 2, but I'm actually not. Instead, and it's okay if you wrote it, instead, the way we're going to write it as, instead of x plus 2 times x plus 2, because it's the same binomial twice, we can write it as x plus 2 squared, and that equals 45. And that's what we were trying to do, is to get it to be like that. Now, you could solve for x here. You could go further. You could square root both sides. You'd have a plus or minus over here, and then subtract 2, simplify the radical, and you get the same answer as you would if you did the quadratic formula. It's another option to that. But we don't want to go further here. This is the end of completing the square. You could then go forward with this and solve for x, but we don't want to go forward here because we're just trying to get this far today. And so that's really it. We need to first set it equal to the constant. Then, if there's a is not 1, divide by a, but that doesn't always happen. Add b over 2 squared on both sides, factor simplify. All right, I want to do this again, this time with a y squared expression. This is supposed to be a y in here. Sorry about that. So y squared minus 12y minus 41 equals 0. First, the constant 41 again needs to go to the other side. So y squared minus 12y equals 41. Add 41 to the other side. Then comes your b divided by 2 squared phase. So this time the b term is negative 12. Divided by 2 is negative 6. Squares, so negative 12y. But divided by 2 is negative 6. What am I doing? Negative 12 divided by 2 is negative 6, but it squares to be 36. And it's always going to be positive because after you divide by 2, you square. So even if this is negative, when you divide by 2, then square, it becomes positive. Dividing by 2, we could still be negative, but after you square, negatives always square positive because a negative times a negative is positive. So we add 36 on both sides. Then, now this is a square trinomial, we can factor it to x. What multiplies to 36 and adds to negative 12? Like I said, the shortcut is it's just this divided by 2. Negative 6, negative 6. They multiply to positive 36, they add to negative 12. So it's going to be x minus 6 squared equals 77. And that's what I was trying to get here. All right, so that's completing the square for x and y individually. What does this have to do with circles? Well, what we can do is we could put it together in one expression. See how there's x squareds and y squareds here like circles do? I want to turn this into a circle-looking equation. And so basically what we have to do is complete the square just for x and y individually. So step one is group. And what I mean by that is let's get the x's and y's together. Now the x's are right next to each other already, the y's are right next to each other, and the constant's by itself. So it's all grouped together. Step two is complete the square for x and y. So the first step of completing the square, if we look up there, was to move the constant. So I'm going to move that 41 first. X squared plus 4x plus y squared minus 12y equals 41. Then complete the square for the x's. The b term for the x's is 4. So x squared plus 4x. Divided by 2 is 2, squared is 4. So I have to add 4 on both sides. And for the y's, I have plus y squared minus 12y plus, for the b's and for the y's, the b is negative 12. That divided by 2 squared is 36. So I have to add 36 on both sides. So you see, you're completing the square for the x's and you're completing the square for the y's. You're doing the b over 2 squared, add that to both sides for the b term for the x and the b term for the y's. So you're adding a number, you're adding two numbers to both sides. For the x's, it was 4. For the y's, it was 36. Now I could factor this to be x plus 2 squared. That's going to factor to x plus 2x plus 2. Plus, here is my y minus 6 squared, my y minus 6, y minus 6 squared. And simplify this down to be 81. Now that that's all set, I can see the center is 2, negative 2, 6, and the radius is 9. Because now it's a circle equation that we're familiar to, and I could pull out my center opposite signs and square root this number to get my radius. All right, so this video ran a little bit long, so I'm not going to do this last example. What I'd actually like you guys to do is do this example yourself. Use this as a blueprint. Here's your b term for the x's, your b term for the y's. First, you got to move that constant to the other side. Divide these by 2, square it on both sides, square it, add it on both sides. Then factor it to a binomial squared, factor it to a binomial squared, and once it gets to something like this, see if you can figure out what the center and radius is, and I'll give you the answer to that tomorrow in class. See ya.